Hi, Professor. My name is Ayushi Verma,
I'm Kelsey Woods.
and we are presenting our midterm project for Scalable Databases course on data science salaries in 2023. So our problem overview is that the data science sector is a very interdisciplinary field, and there are roles for every single background, no matter where you come from. So there are some broad questions. For example, what kinds of roles exist in this field? And what salaries do they pay? And what are the characteristics associated with these jobs? So the context for Kelsey and I's midterm project is that we are budding data scientists and we are preparing to enter the job market soon after graduating at Pace University. And it would be very helpful if we were prepared and we knew what the data science market landscape looks like to prepare ourselves. So in this midterm, we looked at a data set of data science job roles and their associated characteristics, as well as looking at the salaries. And yeah.
So the data sets we used, one was from Kaggle. It seems to have a lot of different data from other countries, which we weren't sure how that would affect the data until after we analyzed it in the EDA. But the second data set was made by us using a random number generator and combining it through a full merge on the country.
So we did our analysis in three very rough stages. So the first stage was data import and cleaning. We imported our data as a data frame, a pandas data frame. We looked at the raw data and then dropped any null, missing, duplicate, or unwanted data values. And then we performed a label encoding of the data to transform the categorical data values to a numerical data type.
We also did an EDA where we looked at all those different types of data that we imported and created through a histogram distribution, a pair plot, heat map, and scatter plot, which all showed different things that we will go over later on. But I think we found the heat map and scatter plots to be, well, the heat maps and the box plots to be the most helpful.
For sure. And then we also performed some targeted queries of this data and the EDA that Kelsey just described. So we did things like subsetting the data, slicing it, aggregating it, and then obtaining different statistics from these data. And then we wrote some functions as well.
So our key results, if you look at this density distribution plot, the average the average salary in US dollars, no matter what country the person was working from, was from about $0 to $300,000 over the overall distribution. But you would see a peak about 150,000 or 175,000. And we did do a Panda describe to show exactly what those numbers are in our notebook as well. For this scatter plot, you can see that the overall range of salaries increases every year. And overall, you can see that in 2023, you're more likely to not only have what seems to be a higher salary, but you can also still be on that lower end, which is what I'm talking about with the range has obviously increased from 2020 all the way up to 2023. For the pair plot, what I found most interesting is the remote ratio and how that seemed to be affected by the other values that we were analyzing against. So I think there was an issue where the data wasn't collected in the proper way that a data scientist should collect the data. For example, there was only 0, 50%, and 100%, which does not accurately reflect what the market is right now and what roles people are generally in. Because I know there's a lot of hybrid roles that require less or more than 50% that is not displayed here. We see exactly what we were expecting from the other previous visualizations through the salary in US dollar with work year, and remote work ratio also seems to show the exact same thing no matter how you slice it.
And so here we're looking at the top 10 job titles by mean salary. And so we see that, one of the general type of job title has the word lead in it, as in they're a leader of that role, or scientist or engineer. And so that kind of gives you a little idea about what sort of educational background you might need in order to get such a job, which is making, a lot of money.
It would be really interesting to see how this, like their actual educational background to get these roles, because I know a lot of people are just doing boot camps to get data science roles, data engineering roles, for example. And a lot of data science leaders in the field are offering those boot camps. I also think it's interesting that data analytics lead is passing principal data scientist and director of data science, along with the data engineering roles and machine learning software engineers, which you would expect to be higher. And I believe from my own personal search in the job market that the definitions of what these roles are not really defined in the realm of HR very well. So it seems like a lot of people who are data analysts are doing data science work, and people who are data scientists are doing data analytics work. And that's kind of leading to some of the issues.
Exactly. And I mean, that also shows just how interdisciplinary this data science field is, right? Because there's a clear difference between, a person performing data analytics job duties as compared to being a machine learning software engineer. Those require, a very different range of skill sets, and yet they are up here making, roughly the same amount of salaries. And so there really needs to be a good discussion industry-wide, academia-wide, about how to translate, technical skill sets to a job title that accurately reflects those skill sets, like you were just pointing out, Kelsey. And so this is looking at the bottom 10 job titles by mean salary. Interestingly, there's a role here at the very last, in the very last bar, Power BI developer making less than $10,000, which I thought was quite interesting. But it could possibly be because someone's doing like this job as a contracting role or as a part-time role, and so overall what they're making maybe doesn't matter because they have another job that maybe compensates. There's some other really interesting roles here, like 3D computer vision researcher, autonomous vehicle technician, compliance data analyst, data DevOps engineer, which sound like maybe they would have more technical skills, which kind of you would think that maybe they would be getting paid a lot more. But what I did notice in this data set was that these, as you look at the mean salaries of all unique 93 job titles, the bottom subset of that data frame, which is, here, presented here, they were singular data titles. So the data is for example, for one 3D computer vision researcher at one company. That's one row in the data set making close to $20,000. And so that speaks to maybe missing data perhaps, or maybe this data could be augmented somehow. But it's still a really interesting peek into what are these singular data job titles, begging the question, why are they making this amount of money?
So this is a look at the overall distribution of salaries, which tends to be around, I would say, 80,000 to 175,000 in US dollars, which I found to be very interesting because it seemed very different throughout the past distributions where they were showing like up to 300,000, and which you do see is a quartile, but it makes sense that the data would be distributed this way with how the density would be for the quartiles. But I guess I'm just saying I really like how this is showing a different view of the data that otherwise we wouldn't have had with just a density plot. I'd also like to point out that the outliers at the top, as you can see through the diamond shape, would have to be removed since they appear to be noise that would affect any further analysis that we would do. For example, if we wanted to do some machine learning, we would have to remove that noise.
Yep. So the graph that Kelsey was just talking about is an aggregated view of the entire data set. So not discriminating by year, by employment type, company size, whatever. That was just the entire data set. And so to answer some more specific questions, we decided to drill down by a couple of different features. So the leftmost graph looks at the distribution of salaries by experience level. So the blue bar is a senior level role, the yellow bar is a mid-level role, green is entry level, and red is executive level role. So we see that for entry, middle, senior, there is the spread of the salaries tends to increase as you go up in terms of seniority. But also the range of outliers is quite interesting. So for entry level, the spread is somewhat constrained at the end of the bar. For mid-level and senior, the spread of outliers is a lot wider, showing that there is really a large, what do you call it? Like large, a very large range of roles possibly that are filling out that, those jobs at that level, at middle and senior level roles. Interestingly, the spread for executive level roles is remarkably even. There's a very decent spread, very firm, and then not a lot of outliers. So that was just an interesting observation. And then the middle graph is looking at the distribution by company size, where yellow is a small sized company, green is a medium sized company, and L is a large sized company. And we see that there is a very, very small, there's a smaller spread for salaries at small sized companies. So maybe you'd be better off working at maybe like a medium-sized or a large-sized company, as they're making slightly more or maybe a lot more than people at small-sized companies. And then the final feature that we looked at in terms of distribution was the employment type. So the blue bar is full-time employment, yellow is contractor, green is freelancing, and red is part-time. So we see that the spread for freelancers is very, very small, and it's a very tiny spread of salaries way below 100K. I think this would be closer to 50K, 75K maybe. And there's not a lot of spread. The spread gets a little better for people working in part-time roles, but again, that's still a very low salary range compared to the other spreads that we looked at. Contractors don't seem to be doing that much better, very narrowly constrained to roughly just under 100,000. But there is a fuller spread and distribution for full-time employees.
I'd also like to point out that the use of data visualization techniques that were used, for example, the primary colors, the different sizes of the graphs so that you can really see we tried to keep the sizes pretty uniform, but if it were hard to see, for example, a quartile in the distribution, we would enlarge it a tiny bit, but we tried to keep everything uniform, primary colors, so it's really easy to visualize, that kind of thing. Also, everything is labeled, so at least if you look through the data dictionary, you could tell, okay, a company size L means large. We also did two correlation matrices So we have a giant heat map on the right that includes all of the variables, including label and coding. And then on the left, we have a correlation matrix heat map, which shows the different more important features to what we were looking at. So for example, the salary in US dollars compared to work year was a positive correlation, while the other two, which is remote ratio and work year themselves, were both negative correlations. I think that's important to point out. We can't determine by looking at this which way it's going, but we can tell you that there is a negative association between them.
And so here we break down the mean salaries by each of the features that we just talked about. So looking at the average salary for each employment type, for each remote ratio, and for different company sizes. And then we also looked at the top five the top five salaries for countries where an employee was a resident, and also the top five salaries for different company locations.
I found employee residents to be very interesting because it seems like the top, well, most out of the top five were not in the US, or US wasn't even in the top three. So I found that to be an indication that we need a lot more further research and a more US centered data set, since both Ayushi and I plan to work in the US, at least to my knowledge. Yeah.
Yeah.
After graduation. So it would be prudent of us to look more into the market that we hope to enter, and we're both already in.
For sure, for sure.
But thank you for coming to our presentation. If you have any questions, please email us at our PACE email, and we appreciate your time.
Thank you.
Thank you, Professor.
Thanks.